Hey, Physics 30 is forgot to give you an explanation of how the Eddy tube worked, that copper tube with the magnet that fell through it. Why did the magnet slow down? So this is an application of Lenz's law. So you have to imagine that that copper tube is just a tightly wound solenoid of wires in a circular motion, because that's all it really is. It's just a bunch of copper, a bunch of electrons that are allowed to move around and circle up and down, all different directions around that copper tube. So the magnet that we're going to drop through is going to pass through the solenoid there. The solenoid, right? So we're going to pass this magnet down. Doesn't matter which way we put the magnet. We can put the north side down or the south side. The effect will be the same. So as we pass that magnet through, it's going to produce a magnetic field out of the north into the south, right? So out of the north into the south. So that magnetic field, as it passes through the tube, will cause a change in magnetic field within that tube, within every single layer of electrons within there. And as it does that, it's going to produce a current, right? So it's going to produce a current, according to Lenz's law, it's going to produce a current in such a way to try to oppose the motion of this magnet. So let's just look at a section of this part right here. So let's just look at this piece of the copper tube at this point. Okay. So as the north side is coming down here, it's going to produce a north on the top here and a south on the bottom to try to oppose the motion, to try to force this back upwards, because gravity is pulling it down. Okay. So it's going to try to oppose that motion. So to produce this magnetic field within the tube, a current is produced in the tube itself in a circular manner. So you're going to use your left-hand rule, put your thumb up. You're going to notice that the current is going to come around the front to the left, around the back to the right. So it's going to go around that direction. So the current in here is going to go this way. My electron flow is going to flow around the front, around the back, and then around this other side here. And it's going to do that at that point there. Okay. So that's going to slow it down as it enters the tube. So when it enters into the tube, there's also going to have a different effect as well. Well, not really a different effect, but it's going to apply twice. So let's imagine that we are inside the tube here. We have the magnet, and let's say the magnet is about halfway through the tube now. Okay. So again, we have the north side here, we have the south side here. It has a magnetic field generated out the front. It's going to wrap around and then come back to the top here. Okay, so that's my magnetic field. So on the bottom, just like at the top, just like before, the bottom part of the tube is going to try to stop it from moving down into it. So that's going to happen down here as well. So let me just get a different color here. So there's this part of the tube down here. A north is going to be generated here, a south down here, and then we're going to get the same current that we had before. So we're going to get a current that's going to flow this way, around the tube, around the back side, and then around this side. So that's just based on the left-hand rule. So that's going to produce a north above. So I put my thumb upwards, and then my fingers are going to curl this way, around the front to the left, and then around the back to the right. Okay, above the magnet, though, there's more wire up here, the change in magnetic field caused by these magnetic fields that are coming down and towards it. So above this, the current is going to be produced in a different direction, because what it's going to try to do is going to try to attract this magnet back up. It's going to try to stop it from moving downwards. So there's going to be a north here and a south up here. So the top part of this magnet is now the opposite direction. Down here, the north is facing up. Down, up above it, the north is facing down. So I can put my finger down, my thumb down, sorry. My finger's going to wrap around the other direction this time. So they're going to wrap around this way. So that's my electron flow for both of those, right? So as it does this, as it continues moving through, the magnets will just get smaller or bigger depending on which side the magnet is on, but it will just follow it down, slowing it down all the way. And just before the magnet leaves the tube here, the whole top part here will be a big north at the bottom and south at the top, slowing the magnet as it goes down. So that's how an eddy tube works. That's why it slows it down, because it's generating current within the tube itself to make a magnet, electromagnet out of the tube to slow the magnet's descent. Okay, see you guys in the next video.